Classification of electrical networks. Now there are different types of electrical networks: active network, passive network, unilateral network, bilateral network, lumped network, distributed network, linear network, non-linear network. Now these two, active network and passive network, these are based on presence or absence of sources. Unilateral network and bilateral network, these are based on direction of current. Lumped network and distributed network, these are based on separability of components. Linear network and non-linear network, these are based on characteristic or linearity. Now let's see one by one. First of all, let's see linear circuit or linear network. We all know that linear means straight line. A linear circuit means characteristics in between voltage and current are linear. As we can see, this is called as VI characteristics. On x-axis voltage and on y-axis we have plotted current. So here we are getting a straight line. This is a linear. This means that in linear circuit the current is directly proportional to voltage. Now what is meant by proportional? As we increase the voltage, current also increase. A circuit whose circuit parameters are resistance, inductance, capacitance, waveform, frequency, etc. These are called circuit parameters, are always constant irrespective of variations in voltage or current, is known as a linear circuit. So here we can see in this circuit, this is a linear circuit. Now why this is linear circuit? This resistance is constant, this inductance is constant in this circuit, whether we change voltage or whether we change the current, these two remains constant. Then next is linear circuit obeys Ohm's law. So always remember that linear circuit obeys Ohm's law. So this is a linear circuit and these are the VI characteristics of linear circuit. Then next, let's see non-linear circuit. The circuits that contain at least one non-linear element are called non-linear circuits. Here we can see this circuit consists of one non-linear element. This diode is the non-linear element. Diode, BJT, JFET, MOSFET or semiconductor devices are the non-linear elements. A non-linear circuit means characteristics in between voltage and current are non-linear. Here we can see this is non-linear. We are getting a curve-like shape. When we plot a VI characteristic of a non-linear circuit, then we get a non-linear characteristic. A non-linear circuit is one whose parameters change with voltage or current. Diode, BJT, JFET, MOSFET or semiconductor devices are the non-linear elements. So here we can see in this circuit, this diode is a non-linear element. If all the elements in the circuit are linear, but only one element is non-linear, then that circuit will become a non-linear circuit. Non-linear circuit does not obey Ohm's law. Next we will see unilateral circuit. Unilateral circuit allows the current flow only in one direction. Uni, that means one. So unilateral circuit allows current flow only in one direction. The VI characteristics change when the polarity of the applied voltage is reversed. So remember that its VI characteristic changes when we change the polarity of voltage. VI characteristics in the first and third quadrant are not identical. So here we can see this is first quadrant and this is third quadrant. So these characteristics are not identical. This is different and this is different. This is when we give forward bias, and this is when we give reverse bias. So forward bias characteristics and reverse bias characteristics are different. Diode and BJT are the examples of unilateral element. Here we can see in this circuit, this is a unilateral circuit. This diode allows the flow of current in only one direction. That means the current will start flowing from this positive terminal and come back to this negative terminal when this switch is on. This is forward voltage. Now when we turn on this switch, then the reverse voltage will apply and the current will start flowing from this positive terminal up to this negative terminal. But here this diode will block this current. So we get characteristics like this. Up to this mark, we don't get any current or very little current. And after this breakdown or avalanche breakdown, we get large amount of current. So this is called as unilateral circuit. Circuit that contain at least one unilateral element are called unilateral circuit. Then next is bilateral circuit. So remember that bi means two or both. So bilateral circuit allows the current flow in both direction. So unlike unilateral circuit which allows the flow of current in only one direction, bilateral circuit allows the flow of current in both direction. The VI characteristics not change when the polarity of the applied voltage is reversed. Here we can see this is the VI characteristic of a bilateral circuit. So as we can see, we are getting the straight line. This is the VI characteristic when the forward voltage is applied or when the circuit is in forward bias, and this is the VI characteristic when the reverse voltage or reverse bias is applied to the circuit. Then next is VI characteristics in the first and third quadrant are identical. So here we can see first quadrant and third quadrant characteristics are same or identical. Resistor, inductor and capacitor are the examples of bilateral elements. So here this circuit is made from only resistor. So instead of resistor, it may be inductor or capacitor or combination of all of these. So it will be a bilateral circuit. That means its VI characteristics will be like this. Then next is circuits containing only bilateral elements are called bilateral circuits. So remember that the circuit to be bilateral, its all the circuit elements should be bilateral elements. Then next is active network. When a network contains energy source, it is called active network. Here we can see this is a active network or active circuit, here it consists of energy sources. This voltage source is an energy source. This current source is also a energy source. So this is called as active network. An energy source may be voltage or current source. So either if it contains a current source or a voltage source or both, then it is called as active network. Next is passive network. So unlike active network, the passive network, if a network does not contain any energy source, then it is called as passive network. So here we can see it does not contain any voltage source or current source. So that's why it is called as passive network. Next is lumped network. If the network elements can be separated physically from each other, then they are called as lumped network. Here we can see in this circuit, we can separate these elements. So it is called as lumped network. We can separate this inductor, this resistor, this capacitor, and all of these we can separate. So it is called as lumped network. Next is distributed network. If the network elements like resistance, inductance, and capacitance cannot be physically separable, then it is called as distributed network. Example is transmission line. In transmission line, we cannot separate resistance, inductance, and capacitance. So these are the classification of electrical networks.